So we're going to take some notes on geometric series. So for a finite geometric series, finite's important here. Finite, remember, and means that it has an ending. We use the equation S of n equals the multiplier times the last term minus the first term divided by multiplier minus 1. So we can put that in sequence notation. That's r times t of n minus t of 1, all divided by r minus 1. And that's given, or assuming that t of n is in the form a times r to the n minus 1. A being that first term and r being your multiplier. We can also derive this to be this equivalent to a times 1 minus r to the power of n, all divided by 1 minus r. I can show you the steps if you're interested, but there's just kind of a lot of manipulation to turn this into that. But you can use either one all the time. So I'm going to do an example using both ways to show you that it works. So our example here is going to be 1,000 plus 600 plus 360 plus 216 plus 129.6. So we could add all these up. There's only 5 terms. They're not a big deal. But I just want to show you again how both of these work. So here our a value would be 1,000. That's our first term. And our multiplier would be 0.6. So if I use the first way, S of 5, 5 being the sum of the first 5 terms. So my multiplier is 0.6 times t of n. So I'm going right here. T of n would be 1,000 times 0.6 to the power of 4. Again, because you're plugging in 5 and then minus 1. Minus the first term, all divided by 0.6 minus 1. And yeah, I know right here we know the last term, but sometimes it'll be a dot, 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 or it'll give it in function notation. So this is equivalent. So if we have 0.6 to the 4th, we multiply by another 0.6. We have 1,000 times 0.6 to the power of 5 minus 1,000 divided by negative 0.4. And then you can just use your calculators. We get 2,305.6. And then if we do this the other way, hold on. So if we do this the other way, sorry, it's S of 5 equals 1,000, that's our A, times 1 minus 0.6 to the power of 5, all divided by 1 minus 0.6. This is 1,000 times 0.92224, all divided by 0.4. Multiply that, divide, we get the same answer. So again, it doesn't matter which of these you use. They both kind of come in handy at different times. So I'll do it in another example here. So if I give you this form, sigma notation, so k equals 1 to 8 of 3 times 5 to the power of k minus 1. I'm going to go ahead and use this second form here. So this is equivalent. So my A value is 3 times 1 minus R. R is my multiplier. My multiplier is 5 to the power of 8 because we have 8 terms, all divided by 1 minus 5. So I get -4 in my denominator. My numerator is -1,171,872, which gives me 292,968. Another example. So you could be given other information. So they could give us the first term is -2. The last term, t of n, is -512, and the multiplier is 2. So if they give you all of this information, it seems like the top equation would be easier. Otherwise, you have to figure out the number of terms to use the bottom one, which you could do. It's just a little bit more work. So S of n here is equal to the multiplier 2 times the last term is -512 minus the first term is -2, all divided by 2 minus 1. So -1024 plus 2, because we're subtracting a negative, divided by 1, we get -1022. Okay, so that's for a geometric series. Oops, sorry, you can't quite see the end there. For a infinite geometric series, with the absolute value of the multiplier being between 0 and 1. So it can be negative, but again, the absolute value is between 0 and 1. It's just the sum is equal to A divided by 1 minus R. So I'll just put a few examples down here. So here, if I do 12 plus 6 plus 3 plus 3 halves, ... So we can see our A value is 12 and our multiplier is 0.5 or 1/2. We get that the sum equals 12 divided by 1 minus 0.5. 12 divided by 0.5 is equal to 24. Another example, -2500 plus 500 minus 100 plus 20, ... So again, our first term, -2500. Our multiplier, we can tell it's negative because they're going between positive and negative. So our multiplier here is -1/5 or -0.2 if you prefer a decimal. So our sum is equal to -2500 divided by 1 minus -0.2. So -2500, sorry, divided by 1.2. We get -6,250 divided by 3. We can also do these in sigma notation. So if this example is the sum from n equals 1 to infinity of 2 times 3 to the power of n minus 1. So here our first term is 2 and our multiplier is 3. So this is going to have no sum. And the reason being this multiplier right here is greater than 1. So you're just adding bigger and bigger and bigger numbers, so this just keeps growing. But we'll give you one last one. So to infinity of n equals 1, the sum of 4 times 0.8 to the power of n minus 1. So our first term is 4, our multiplier is 0.8. So the sum here is 4 divided by 1 minus 0.8. 4, sorry, I gotta turn the paper a little bit, divided by 0.2, which is 20. That's it for notes on geometric series. Hopefully this helped. Let me know if you have other questions.